Hi all, this is Mr. Yeager for Honors Chem, and we are continuing with our unit on chemical reactions, and we're going to look at types of reactions in this quick video. So we already figured out how to balance, but now the next part is classifying, and I feel like this part is something that can go pretty quick because you kind of can just look at the reaction and go, it's this type. So what we need to cover is just what are those 5 types of reactions and how can I tell which one is which, okay? So, synthesis. Synthesis is our first type of reaction. I say first, it's just the first one I have listed here. Synthesis is where you have 2 atoms of compounds and they're going to combine together to form a larger compound. You'll see that I'll write all of these reactions with like A, B, AX, AB, all that stuff. It's just showing you like A is one compound or element, B is another compound or element, and then what happens is they all combine. Okay. There might be like an extra element that forms as well in some way or some other different type of compound. All right, that's related to the elements, but the whole idea is that you get a larger compound from those initial reactants. So you can see my example there, it's already balanced too. Mg plus Cl2 will form magnesium chloride. 2 elements combine to form a single compound. Okay, so that is synthesis. A plus B forms AB. The opposite of that is a decomposition. A decomposition is where you have the compound and it breaks apart. All right? So you have the 2 elements together and then it breaks into 2 or more pieces. All right? In general, we'll stick with 2, but you'll see some reactions where it might be a 3rd or 4th product as well, something smaller. Okay? So that's your example of decomposition. AB produces A plus B. Single replacement. This is one where we will have a compound and then a lone element. And what happens, and the lone element might be a diatomic, so don't be surprised by that. That's still a lone element. Okay? But what you can see here is where one element will come in and kick the other element out. All right? There's a single element being replaced. All right? So that is called single replacement, a single element being replaced. Now this is showing you the first element being replaced, so I do need to kind of explain just a little bit more of this one. Okay? What we basically will run into is a metal will replace a metal. Okay, there is an exception with that. Okay, except, you know, a metal will also replace hydrogen. Okay, so that's another. Metal will replace metal or hydrogen. I should have written that, or hydrogen. Or a halogen will replace a halogen. Okay, so fluorine will come in and kick the chlorine out. So, you know, either the first element is being replaced. Hydrogen's always written as the first element in ionic compounds. This is, again, almost always ionic compounds. Okay, or the halogen replaces it. Okay, the halogen replaces the halogen. Now, I just want to mention it, but we're not necessarily using it too much. This is all determined. Not every element is strong enough to kick out another element, all right, it turns out. And so we have what's called the activity series. And this is showing you, this is a chart that's just showing you, as you go down this list, that metal gets weaker and weaker and weaker. And what that means is elements above can kick out any element below it. Elements below it cannot kick out any elements above. So what we're saying is lithium can kick out any other metal. Lithium is very, very reactive and will be able to punch out any other element and take its place in the compound. But if I have chromium alone and it wants to try to kick out magnesium, that won't happen. Okay? So they have to be above on this list to kick out the element below it. Now, I will say in my class, we're just going to go ahead and just practice like everything replaces everything. But for those obviously moving on a little bit to AP Chem, College Chem, we'd have to pay attention to this in a great deal. Okay. On the other side, we only have our 4 halogens: fluorine, chlorine, bromine, and iodine. All right. Fluorine's the strongest, iodine's the weakest. So iodine can't actually kick out anything. And what would happen is we would just write no reaction would occur. All right, if it tried to replace bromine. But chlorine can replace bromine and iodine. All right, fluorine can replace chlorine, bromine, and iodine. So that's what the activity series is trying to show. Okay? You can see down here our weakest metals are silver, platinum, and gold. Okay, they're very, very weak. All right, double replacement. Okay, Double replacement is where now you have two compounds and they switch partners. That's what a double replacement is trying to show you. All right. And again, trying to show how we can identify this. You know, we got A, X, so Li is A, Cl is X, plus B, Y, Na is B, F is Y, and so it's going to form AY plus BX. All right, AY plus BX. Right now, again, I'm just having you be able to look at it and go, that's a double replacement reaction. And hopefully already, I mean, these are the four that kind of can be possibly confused with each other. We have one more, but it really stands alone. We should be able to identify the type of reaction based on what the reactants are. Okay, pretty much. I mean, and that's what we're going to get into with predicting products, is you can predict what's going to form based on what reaction type you see is going to occur. All right? So if there's two compounds, pretty much always it's going to be a double replacement. If it's two elements, it's a synthesis. If it's a compound by itself, it's a decomposition. If it's a compound and a single element, it's going to be a single replacement. All right? So it'll be pretty clear which ones are which. The last one we got here is combustion. Okay? Combustion, like I said, kind of stands alone. A combustion reaction is a hydrocarbon, which is a compound with C and H. All right? It can also possibly have O, oxygen, I will say that. But a hydrocarbon is specifically, it has carbon and hydrogens in it. It reacts with oxygen to form carbon dioxide and water. All right? And this is a covalent compound. Let me be clear. It's not an acidic compound. It's not an ionic compound. This is a covalent compound, is a hydrocarbon. But the nice thing about combustion is you already know what the two products are always going to be. When you have a hydrocarbon reacting with oxygen, we always form carbon dioxide and water if you are predicting the product. Okay? And you can see that's our next thing. That'll be our next video. All right? So let's take some time to kind of look at some reactions and see if we can identify some of them. This generally, again, goes fairly quickly. So if I look at my first one up here, this big one, I'm looking at the one above the red line. What type of reaction do I have here? Again, some of you might already be like, it's this. I have AX plus BY. Well, Ca is my A compound. It's now with the SO4, which is Y, and Al, which is B, is now with the X. That's a double replacement. A lot of times we will abbreviate it DR for double replacement. All right. There you go. I mean, that's pretty much it. I mean, in the end, what we might do is I might give you a reaction. You have to write it out. You have to balance it and then tell me the type. But for now, it's already all nicely balanced for you. You're just telling me the type. Right here, this one might be a little confusing for some. But right off the bat, you only have one reactant. And then you have two products. So that has to be a decomposition, which we sometimes just abbreviate as D. All right? But there you go. Let's look at some more. All right, this one right here. Again, only one reactant, two products. They're technically smaller, okay, than what the initial reactant is. So this is another decomposition. This one right here. So this is a neat example where you get actually compound and compound, but only form one product. So that must be a synthesis. Again, that could be where it could be a little confusing going, I think this might be a double replacement. But this would be one I wouldn't make you try to figure out. And like, you're not going to have synthesis where you have to actually predict this product. That's a little bit too difficult. All right? But you should be able to still identify that as a synthesis. This last one here, I'll just write this as A. I'll call this BX. And what do I see happening here? PB is going to come in and kick the hydrogen out. So B is now alone, and I have AX. That is a single replacement. All right? So that's what we're going to basically practice quite a bit, and that's it. All right, pretty quick little talk. Have a good day.